It is 8:55 a.m. Eastern on January 29th, and you are looking at a live view of the Falcon 9 as it awaits its targeted 9:07 a.m. Eastern Time launch from Cape Canaveral Air Force Station in Florida. Good morning from Spacex headquarters here in Hawthorne, California. My name is Lauren Lyons, and I'm an engineer on our Starlink team here at Spacex, and welcome to our live webcast of our fourth Starlink mission. To date, we have launched three sets of 60 Starlink satellites. One set back in May of 2019, another in November, and the most recent just a few weeks ago on January 6th. This network of relatively small but advanced satellites is designed to bring high-speed, low-latency broadband internet to people all over the globe. By design, these satellites will be able to service areas of the globe where connectivity has been unreliable, too expensive, or completely unavailable. Now today we're going to attempt to recover this Falcon 9 first stage for the third time, this time on the drone ship Of Course I Still Love You, which is currently stationed about 350 nautical miles off the eastern coast of Florida. We'll also be attempting to recover both payload fairing halves today during using our two fairing recovery vessels, Miss Tree and Miss Chief.
The second stage is what will carry the Starlink satellites to an altitude of 290 kilometers above the Earth's surface. At this time, second stage is fully fueled and liquid oxygen loading is currently underway on both first and second stage. The stack of 60 satellites is safely enclosed inside of the 17-foot diameter payload fairing, which is the pointed enclosure on the very top of the rocket, and we've got a nice view of the satellites stacked up right there. These are flat satellites, so you can see that there on your screen. And once we reach the vacuum of space, we will deploy the fairing as the second stage continues on its journey to its final orbit.
Today, most of your satellite internet services come from geostationary satellites, or GeoSats. A single GeoSat will serve a fixed but broad area and is typically placed about 35,000 kilometers or higher above the Earth. Now, one of the main drawbacks of that high altitude is high latency, or delay, in that signal that's provided because they're so far above the Earth. Starlink, on the other hand, is a constellation of multiple satellites that orbit the planet, but at much lower, at about 550 kilometers. Because of this low orbit, latency is much lower than with satellites in geostationary orbit. This enables Starlink to deliver services like seamless video calls that are usually not possible on other satellite internet systems. And because Starlink satellites fly in a global constellation, we can bring high-speed internet to places that previously had terrible service or no service at all. Some of the most exciting opportunities for Starlink are rural or remote locations where traditional fiber or cable just isn't practical. And Starlink can also deliver high-speed internet to locations where fiber and cable aren't possible at all, such as a cruise ship or an airplane. Building a constellation that can provide this level of service is incredibly challenging, but we are making steady progress towards that goal with every Starlink launch. And one quick note, during our last launch we mentioned that we were experimenting with a darkening treatment on one of our satellites. This is part of an effort to minimize reflections from the satellites that may be distracting to some astronomers during their observations of the night sky. It takes a few weeks for those satellites to reach their final orbit destination, so we don't have the results of that DarkSat experiment just yet, but we'll be sure to share what we've learned as the data becomes available.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
It is T plus 45 seconds, and we've just had a nominal liftoff of our Falcon 9 vehicle carrying our Starlink payload on its way to its targeted orbit. In just about 20 seconds coming up here, we will be passing through max Q.
Falcon 9 is supersonic.
That is the maximum aerodynamic pressure that the vehicle will see, which is the largest structural load that the vehicle sees throughout ascent.
Vehicle is experiencing maximum aerodynamic pressure.
And we've just heard that call out from Max Q. Coming up next in about a minute will be 3 events back to back, starting off with MECO, or main engine cutoff, followed immediately by stage separation, and this is where the first stage separates from the second stage, and then followed by SES-1, which is second engine startup.
MVAC engine chill.
And we should be able to see all 3 of those events live on your screen. There's that main engine cutoff.
Main engine cutoff.
Stage separation confirmed.
You can see the stage separation, first stage separating from second stage on your left screen, and on the right, second engine startup. That's that MVAC engine on our second stage. And there's that bright red glow on the engine. So now coming up in about 20 seconds is fairing deploy, and as Lauren mentioned earlier, we will be attempting to catch both payload fairing halves on our recovery vessels, Mystery and Mischief. It will be unlikely that we will see these live on the webcast, so we'll bring you updates as they become available. But you can also check into our social media for updates as well.
Fairing separation confirmed.
And there's that call out for fairing separation. There's fairing deploy. You can see that on your right screen. Those fairing halves are now making, you can see that on your screen actually, the fairing halves are making their way back to Earth, and hopefully we can catch those on our recovery vessels.
Okay, so we have on both sides of your screen here, we got stage 1 on the left and stage 2 on the right. So a lot of really cool stuff coming up all at once or in rapid succession here in the next few minutes. On the left side, what we're going to see on the stage 1 side of things is at about T plus 6 minutes and 24 seconds, more or less, you're going to hear the call out and hopefully visually see the stage 1 entry burn. That's where we reignite 3 of those Merlin 1D engines, and that allows the first stage to slow down as it re-enters the upper part of the Earth's
Stage 2 is on a nominal trajectory.
All right, as you just heard, stage 2 is on a nominal trajectory. That's really cool. Meanwhile, stage 1 is coasting down, getting ready for that entry burn. That burn's going to last just under 20 seconds. After that entry burn, stage 1 will continue to coast down towards the drone ship, and at about T plus 8 minutes or so, you're going to hear the call out for the landing burn.
Stage 1 entry startup.
All right, you see that entry burn as it started. All right, that landing burn is currently going. Unfortunately, we don't have the video from the vehicle, but we do have the drone
Stage
ship
1
video.
landing light deploy.
Stage 2 is in terminal guidance.
All right, and yes. Awesome. That's the 3rd landing of this booster. 2nd time landing on, of course, I Still Love You.
Falcon 9 has landed. Operators, please proceed.
Very
to
cool.
T
And
plus 11.100.
Safe.
any second now, we should be seeing SECO 1. That is where that second stage engine will cut off.
we've got an exciting update. As you can see on your screen, we were able to catch one of the fairing halves so far. This one is on Miss Tree, and we're still waiting to hear if we are able to catch the one on Mischief, the second fairing half. So exciting news so far this morning. We will bring you updates on Miss Tree and that second fairing half as soon as we get more information. And we've had confirmation of good orbit. So now that second stage is in a good orbit and making its way to its final
Good
destination.
orbit insertion for satellite deploy.
And there's that call out. Now that we're in a good orbit, we'll be coasting for the next 15 minutes or so.
That the deployment sequence looks a little bit different from what you'll see on a typical launch. The satellites will slowly disperse upon deploy, and they may even bump into one another, which is to be expected. The satellites were designed with this in mind. And we are less than 1 minute away from deployment of the Starlink satellites. Okay, so after the satellites deploy, they are going to, over time, separate from one another and use their onboard krypton ion thrusters in order to space themselves out into their orbital planes and raise their altitude to their operational orbit of 550 kilometers. Our insertion orbit, if you remember, today is about 290 kilometers above the Earth. Here it should be coming up. There we go. Oh, that's gorgeous. That's those 60 Starlink satellites successfully separating from stage 2, and that beautiful planet there is the planet that those satellites are going to provide internet service to, which is super, super exciting. And with that, that brings our webcast to a close. We had a successful mission. We had a great stage 1 ascent, completing the hat trick, launching from 3 separate launch sites. We had the 3rd recovery of this booster. Stage 2 delivered Starlink to its operation or to its targeted orbit, and as you just saw, we successfully separated those 60 Starlink satellites. So, and also we caught a fairing. That's a big deal and super awesome, and we were able to see it in the daytime, which is even more cool. So a big thank you to the 45th Space Wing for range safety and to the FAA for licensing today's successful launch.
We'd also like to thank all of you, our viewers, for tuning in this morning. Follow our website and social media platforms for updates on our next missions and milestones. And until next time, have a great morning.